We will start within 1 minute. Just wait 1 or 2 minutes. We will start. Now we will see the next numerical on the beams. So the next problem is, my voice is audible to all? Let me know. Okay. So the problem is find the support reactions. Find the support reactions. Find the support reactions of the beam shown below. Shown below. So we will draw the diagram now. So this is the beam. Now here at this point, this type of support. This is the support at point A. Now the loading, here is the load of 4 kilonewton which is acting. 4 kilonewton. Next load is this load, which is of 5 kilonewton. And again one more load which is of 5 kilonewton here. Yeah. And here the roller is there, roller support is given to us, but it is inclined roller. So here the support will be like this. This is the roller support, but it is kept on the inclined plane. This is our plane, and this angle is given as 30 degree. And these forces are, this is 4 kilonewton, 5 kilonewton, and 5 kilonewton. The angle of this force, this angle is 45 degree. And now we will write the distances. So the total span is 10 meter. So here I will write the distances. So this much of distance is 2.5 meter. The distance between these two forces, it is 3 meter. It is 3 meter. And the distance from this point of this force, it is 5 meter. So I will write now. This is 2.5 meter. This is 5 meter. This is 3 meter. And the total distance, total span up to this point B, it is 10 meter. Total is 10 meter. Let us call this point as point B. Now you can see over here, this much of distance is 2.5 meter. And from this point up to this force, this distance is 5 meter. So if this total is 5, this is 2.5, then the distance between these two is also 2.5. Next is distance between these two is 3 meter. Okay. And the total span is 8 meter. Sorry, total span is 10 meter. So this distance will be 5 plus 3. So this will be 8 up to this point, and total is 10. So distance between these 2 points, it is 2 meters. So the distance between these 2 points, so I will write over here again. So this distance up to this point, it is 2 meter. So this distance, this is 2 meter. Okay, so this is 2 meter. Now we need to solve this numerical. We have to solve this now. Here, first of all, what we will show the reactions. First of all, we will show the reactions. Now see, this type of support is given. Now inclined force is also given. So this is your hinge support, where you will get 2 reactions. One is vertical, another is horizontal. This is your roller support. How many reactions are there for the roller support?
One reaction.
One reaction. But that reaction, what is the significance of that reaction? How it will be?
It is perpendicular to the base.
Okay, it is perpendicular to the surface on which the roller is resting. कुठल्याही सरफेसला परपेंडिक्युलर घ्यायची नाही. रोलरची रिएक्शन घेताना ज्या सरफेस वरती रोलर ठेवलाय त्यालाच परपेंडिक्युलर घ्यायची रिएक्शन. So now I will draw the reactions quickly. So here I will draw my first reaction. In this diagram only I will show the reactions. This is vertical reaction at A, VA. This is the horizontal reaction at A, HA, and this is the vertical reaction at point B. Okay, so here this is my reaction RB, because only one reaction is there. Here we have to find out resultant reaction, that is VA and HA. We need to find out RA from VA and HA. We have seen in one of the numerical. Okay. So now see, this reaction is inclined. Now if you see the diagram, okay, now if you see the diagram, in this diagram, this reaction is horizontal. We can use in summation Fh. This is vertical in summation Fy. Same thing is there. But this force of 5 kilonewton, and now this reaction Rb. These two, this force and this reaction Rb, both are inclined. Okay, it is not parallel to X, and also it is not parallel to Y. So we have to resolve these two. We need to resolve these two. So for the resolution, here this is the point of contact of this 5 kilonewton force. So how do I resolve? I will draw one line parallel to Y and another line parallel to X. So this is the another. Okay, in such a way that your main force should come in between these two components. So I have got the components now. Now this angle is 45 degree. So this will be 5 cos 45. This will be 5 cos 45, and this is 5 sin 45. Okay. Now for this case, I will draw the separate diagram so that you will understand how to resolve this RB. Okay. For this numerical only, I am drawing the separate diagram. For rest of the numericals, now you can understand from this. Same thing you need to do. Here is RB. I will draw the RB like this. This is RB. Okay, so this is the reaction RB. And here is the plane. This plane is like this. Okay. And this is the horizontal. And this angle is given to us as 30 degree. This angle is 30 degree, and this is the plane, which is the surface to which this reaction is perpendicular. This angle is 90 degree. Now this is my point B. Now at point B, if I draw vertical line for this point, it is like this. Okay. Now you can see, if I drop the perpendicular from this point, okay, this vertical line just I extend. This vertical line just I extend, it will move forward. See, this is the vertical line. If I just extend this, it will come like this. Okay, here. Now the angle between this horizontal line and vertical line, it will be also 90 degree. This is my vertical line. Okay, and this is the horizontal line. You know that. So the angle between this vertical line and this horizontal line, this is also 90 degree. Now you can see this is your inclined surface, which is inclined at an angle of 30 degree with the horizontal. This RB reaction is perpendicular to this surface, and this second vertical line is perpendicular to this horizontal surface. Okay, so if this angle is 30 degree, then this angle must be 30 degree. How it is 30 degree? Angle between the lines is angle between their normals or tangents. That theorem I have already explained to you. Angle between the lines is angle between their normals or tangents. ही केस ओके. असंच तुम्हाला एक्झाम्पल घेऊन मी शिकवलेलं आहे, पहिल्यांदा सांगितलेलं आहे हाऊ द थेरम इज रिक्वायर्ड ओव्हर हिअर. So if this angle is 30 degree, now if I try to resolve the RB with this angle, so I will get one component in this direction and another component in this direction. One component is parallel to Y, another component is parallel to X. Okay, so these are the two components. So now if this angle is 30 degree, what is the value? Value is RB. We don't know still what is the value of RB. Then this will become RB cos 30 and this will become RB sin 30. Okay, so this is the resolution of RB. As RB now it is not vertical, it is inclined. So we have to resolve the RB. Okay, to solve the numerical further. So let me know, is there any difficulty in the resolution of RB, whatever we have done over here? Anybody is having any doubt in this?
No, sir.
Okay. So this is the resolution of RB. अशा प्रकारे तुम्हाला RB ला resolve करायचे. Now that resolution I will show over here in this main diagram. So this is our RB, which is parallel to Y. This is the reaction RB parallel to Y, and here it is parallel to X. So this is our RB sin 30. I have shown in the bigger diagram, you can refer that. And here it will be RB cos 30. So further, if we solve this problem, now we need to find out the reactions. So what we will do first, we will take the moment at A equal to 0, so that HA VA will become 0 and we will get the value of this RB. So if I apply moment summation M about A is equal to 0, then all your clockwise moments are positive, anti-clockwise moments you should take it as a negative. Now here, this I'm taking the moment at this point A. So HA is passing through point A, so its moment is 0. VA is also passing through point A, so its moment is also 0. Now here you can see RB sin 30. If you extend the line of action of this RB sin 30, it will also pass through this point A. If you extend its line of action like a dotted line this way, and it will come passes through point A. So the moment of this RB sin 30 is also 0. Okay. So RB sin 30 ची movement किती असणार? 0, HA 0, VA 0. Now this force 4 kilonewton force. So this 4 kilonewton, what is the distance? Distance is 2.5 meter, because we are taking the moment at point A. So we should calculate all the distances from point A. So it is 2.5 meter. So its moment will be 4 into 2.5. Okay. Now you can see this force is moving down. मग हे खाली चाललाय ना फोर्स, तर जाऊ द्या थोडं खाली आणि नंतर रोटेट करा त्याला. So if you rotate it about the point A, it is in clockwise direction. So positive, it is positive. Next force is this 5 cos 45. आता हे 5 ला तुम्ही रिझॉल्व्ह केलंय, मग या 5 ला सोडून द्यायचे, दोन कॉम्पोनंट कन्सिडर करा कॅल्क्युलेशन मध्ये. So now this 5 cos 45, again this force is moving towards right. But when you extend its line of action backwards, you will observe that this 5 cos 45 is also passing through point A. Its line of action is passing through point A. So its moment is also 0. So the moment of 5 cos 45 is also 0. Now this 5 sin 45. So for this 5 sin 45, if I see the distance from point A, the distance of this 5 sin 45 from point A, it is 5 meter. This is the distance which is given in the problem. So I will write the equation. It is 5 sin 45. This is my force into the distance is 5. Again, now this force is moving in downward direction, so it will rotate in clockwise direction. If you rotate about the point, the rotation is clockwise. So it is plus. This is plus. Now next one is this 5 kilonewton. This 5 kilonewton. Now you can see this distance is 5. Up to this point distance is 5. From here it is 3. So from point A this total distance is 8 meters. So it is 5 into 8 plus 5 into 8. Then this RB sin 30, I have already told you its moment is 0. Now RB cos 30 it is remaining and the total distance is 10 meter. RB cos 30 is moving upward. So take it as upward and now rotate about the point. थोडं वर उचला आणि रोटेट करा पॉइंटला. So it is moving in anti-clockwise direction. So it will be minus. So it is minus RB cos 30 into 10, which is equal to 0. So therefore, now if you solve this equation, you will get the value of RB. Let me know the value quickly. Solve it now. What is the answer? RB
7.814.
7.814 Newton, kilonewton. Okay, 7.814 kilonewton. Have you got positive answer or negative answer?
Positive.
RB ची व्हॅल्यू पॉझिटिव्ह मिळाली. So you got the answer of RB positive. So whatever direction we have assumed for the RB, that direction is correct. Okay. So this direction, whatever we have assumed for the RB, this direction it is correct. So its components direction is also correct. Okay. So RB's direction is correct. So I will show here in the bracket. This is the direction of RB in this way. It is not vertical and also it is not horizontal. So this direction is correct. Now after calculation of the RB, now you can apply summation Fy equal to 0. You can apply summation Fy equal to 0. Upward forces are positive and downward forces are negative. Now if you see the diagram here, now you are applying summation Fy, forces parallel to y. So first force is Va, which is moving upward, so Va is positive. Okay. The next force is this 4 kilonewton, which is moving downward, so it is negative. So first of all, I will write these two forces. Va is moving upward, positive, minus 4. Okay, minus 4, this 4 kilonewton force. Then next is this 5 sin 45 moving downward, so it is also minus 5 sin 45. And this 5 kilonewton, it is also moving downward. This is also minus. So it is 5 sin 45 minus 5. Then what is remaining now? Now here you can see this RB cos 30. Now RB cos 30 is moving upward, so it is positive. And the value of RB, this value we can keep over there. So here plus RB cos 30 equal to 0. Therefore, VA is equal to, now put the value of RB, so you will get the value of VA. This RB value, what is the value of RB? RB is 7.814. This is the value of RB. You keep this value over here, so you will get the answer VA.
5.76.
Okay, just 1 minute. Okay, so it is 5.76 kilonewton and we have got positive answer, so our assumed direction is correct. Now apply summation fx equal to 0. Now when you apply summation fx equal to 0, rightward forces are positive and forces moving towards left are negative. So here you can see HA is moving towards right. We have assumed the direction of HA in this way. So HA is positive. Then this 5 cos 45, it is also moving towards right. So this is also positive. And minus RB sin 30. So it is moving towards left direction. So it is negative. So here I will write the equation. Equation is HA plus 5 cos 45 minus RB sin 30 equal to 0. Now again put the value of RP. So HA plus this 5 cos 45 minus RB is 7.814 sin 30 is equal to 0. Now when you solve this, you will get the value of HA after solving this.
0.37.
0.37. But you have you got the positive answer, right?
Yes, sir.
So our assumed direction is correct. If you got the positive answer, our assumed direction is correct. If you got the negative answer, then we should change the direction. Now, next is, now you got the value of VA. So this is the value of VA. This is the value of HA. So here you can see, here HA and VA you got these two values. So the resultant of these two will be, if you complete this parallelogram, if you drop vertical line from here and if you drop horizontal line from here, you will get one parallelogram over here, and the diagonal of the parallelogram will represents your resultant reaction, that is called as RA. An angle with horizontal is the alpha A. Okay, so that we need to find out now. So here we can write resultant reaction at A. Resultant reaction at point A. So the resultant reaction at point A. So now how to calculate that resultant reaction? So the formula is RA is equal to under root HA square plus VA square. सेम समेशन fx स्क्वेअर प्लस fy स्क्वेअर जसं तुम्ही घेताय ना, आता फक्त सिंगल पॉइंट साठी एका सपोर्ट साठी. सो horizontal component and vertical component HA and VA, HA square plus VA square. So therefore RA is equal to under root HA is 0.37 square plus VA is 5.76 square. So after solving this, you will get the value of RA.
$5.77.
4.5 point. Okay, 5.77 kilonewton. Okay. Now find out alpha A. So alpha A is equal to tan inverse in mod VA upon HA. So put the value. Alpha A is equal to, you know the value of VA, you know the value of HA. Just put the value, let me know the answer. Now here it will be tan inverse of VA is 5.76 divided by HA is 0.37. So therefore,
216.62.
what is the answer?
216.62.
एवढं येणं शक्यच नाही ना.
86.32.
86.32. See here, whatever answer you are telling now, just think logically. Okay. बघा इकडं तुमचा आन्सर मी लगेच नाही का म्हणलं सांगतो तुम्हाला, मला आन्सर फिक्स माहित नव्हतं याचं. सी इफ आय ड्रॉप परपेंडिक्युलर फ्रॉम हियर, ओके, RA नेमकं कुठे येते आधी समजून घ्या. And if you drop horizontal from here, okay, so this will become a parallelogram. Now your resultant is like this. Okay, your resultant will be like this. आणि अल्फा ए म्हणजे कुठला अँगल असतो तुमचा? So this angle, it is nothing but alpha A. Okay. Now by observing it also, you can say that because this total angle is 90 degree. So this alpha A must be less than 90 degree. This alpha A must be less than 90 degree. म्हणजे ही फिगर बघूनच तुमच्या लक्षात येते की तुमचा अल्फा एचं जे आन्सर आहे ते 90 डिग्री पेक्षा लेस येणार आहे. समजलं का? त्याच्यामुळं लॉजिकली जे आपण कॅल्क्युलेशन्स काढतोय ना ते त्या डायग्रामला पण मॅच करून बघायचे की बाबा आता इथं फिगर मध्ये आपल्याला असं दिसतंय वी आर सीइंग दॅट हिअर अल्फा इज ॲक्यूट अँगल इट कॅन नॉट बी द ऑब्ट्यूस अँगल. Okay, so that is why correct answer is 86.32. And finally now if I show here a diagram, I will arbitrarily take point A over here. This is my point A, suppose this is the point A. Now HA is the horizontal component, correct? Now you can see here HA is what? HA is the horizontal component. What is the direction of HA? It is towards right. What is its value? 0.37 kilonewton. So here I can draw HA like this. See, this is my HA. And the value of this is HA is equal to 0.37 kilonewton. Okay. Then VA. If you see the VA here, this VA is the vertical reaction at point A and it is 5.76 and it is moving upward from A point only. Here also HA is from A point, VA is also from A point. So now if I show here VA will be like this. And the value of VA is 5.76 kilonewton and this is VA. Okay. Now again the same thing. If I extend this horizontal line from this point and if I drop a perpendicular from this point, okay, or I extend vertical line, so this is my parallelogram. Okay. This will be the parallelogram and the resultant reaction will be the diagonal. This diagonal is the resultant reaction. So this is your RA. This is your RA, which is equal to 86 point, sorry, not 86 point, RA किती आला आपला 5.77 kilonewton. So the value of RA is 5.77 kilonewton and this angle you can see alpha A or this angle also because both of them are alternate angles 86.32. See, I am going to tell you. Here you are saying that this angle is alpha A. Okay, but whatever this angle is there, it will be same. असं Z तयार होते बघा इथं. This is the Z. So these two are the alternate angles. You can see if you are saying that this angle is alpha A, this is also alpha A. Because Z, you can see the Z, formation of Z. So these two are alternate angles. So here also the same thing. So this angle alpha I can say, or here also I can write this angle is alpha I because it is automatically it forms Z. So alternate angles. Okay. Is it clear now? समजलं असलं तर पुढचा प्रॉब्लेम घेऊ. Yes, no?
Yes, sir.
Okay. So the next problem is find no, not find, it is a simply supported beam, of length 5 meter carries a UDL of 800 Newton per meter at carries okay, just one correction, sorry, carries, it is not UDL, carries a uniformly increasing load. So it is uniformly varying load basically. It is not uniformly distributed load. It is uniformly varying load. It is given in the problem. So uniformly increasing load of 800 Newton per meter at one end to 1600 Newton per meter at other end. Okay, so the intensity of load you can see at one end it is 800 Newton per meter and at another end it is 1600 Newton per meter, as shown below. As shown below. Full stop. Calculate the support reactions. Calculate the support reactions. Okay. So we need to calculate the support reaction. So I will draw the diagram. So here only we will draw the diagram. What is the diagram now? So this is a beam. Now in the problem you can see that a simply supported beam. The statement is simply supported beam. So beam is having simple supports. So this is my point A. This is point B. So at both the points my support is the simple support. So I will draw the support. This is the support at A. This is the support at B. Simple support is there. Simple support carries only one reaction which is vertical. So RA and RB, reaction RA and reaction RB. Now if you see the numerical, what they have says that the length is 5 meter. So this total length, if I measure this total length is 5 meter. It is 5 meter. Now here you can see uniformly increasing load. Uniformly increasing load means it is increasing from 800 Newton per meter at one end. म्हणजे दोन्ही पैकी एका साइडला कुठे काय 800 Newton per meter to 1600 Newton per meter at other end. So this is the uniformly varying load. So I will draw this load. So here, see, first of all, the load is acting like this. Here the intensity of the load is 800 Newton per meter, and at this point the intensity of the load is it is 1600 Newton per meter, and I will join these two. So this is uniformly varying load. This type of load is given to you. This is called as uniformly varying load. Okay, it is acting like this. You can show the load in this way. So this is the loading which is given on the beam. So now you can see at this end, at this point, the intensity is 800 Newton per meter, and at this point, this intensity is 1600 Newton per meter. Okay, 1600 Newton per meter. Now I want to calculate the reaction at point A and B. You want to calculate the reaction at point A and B. How we are going to calculate now? How to calculate? Can anybody tell me how to calculate this? So see, this is the trapezoidal load. Okay, but we don't have any direct formula for trapezoidal to calculate CG. There is a direct formula for the CG of trapezoid also, but it is quite complicated. So instead of that, what I will do now, see, if the area is given to you is in such a way that it is not a definite shape, then make it a definite shape. So what I will do now, from this point, of 800, I will drop one perpendicular. So I will drop one perpendicular over here. Okay. So this is the perpendicular, exactly straight line. Now you can see that this load which is at the bottom, this has become now rectangular load. Now this load has become a rectangular load. Rectangular load means UDL. This become rectangular load. And the above triangular load, this is your uniformly varying load. This triangular load is the uniformly varying load. Okay. Now here I can write, suppose now if this ordinate is, ordinate this is 800 Newton per meter, then this much of ordinate is also 800 Newton per meter. It will be same at about this point. Okay, this is also 800 Newton per meter. But now when we consider the triangle here, see this total ordinate is 1600. This ordinate is 800. What I have done, we have dropped the perpendicular to this side. So this has become now rectangular load. So now if this is 800, this is also 800, this much. Okay, but the total is 1600. So what is remaining? So this remaining ordinate will be, how much it is?
800.
800, correct. Okay, so this remaining ordinate I will write here only with the different ink so that you can understand. This ordinate for the triangle will be 800 Newton per meter. Okay, आता इथं in this numerical 800 and 1600 is given. That is why, see, in this numerical 800 and 1600 is given. That is why this is divided into equal parts, 800 800. Instead of 1600, suppose 2000 is given, then this will become 800 and this remaining will be 1200. Likewise you have to do it. नाहीतर हे इक्वल इक्वल आहे म्हणून दुसरा कुठला प्रॉब्लेम आला आणि त्याच्यात व्हॅल्यू चेंज असल्या तर तुम्ही तसंच करताल. तर try to understand the logic, what way we are doing. Calculations may be different. Okay. So now I have got these two loads. One is the UDL, another is the UVL. Now my problem is become very, very simple. Okay, see, now pay attention. Here now, you can see, this is the rectangular load. Okay, so I can convert this rectangular load into the point load easily and I can take the moment. So now if I want to find out the RB or RA, I will take the moment either at point B or either at point A or either at point B. So now what we will do, we will take the moment at point A first. Okay. So if I take summation M about A is equal to 0, clockwise movements positive, anti-clockwise movements negative. Now I go back to the diagram over here. Now pay attention. A is moving through RA is moving through point A, so moment of RA will be 0. RB is moving upward, so you can easily calculate the moment of RB. Anti-clockwise minus 5 RB will be there. Now what to do for these two loads? Okay. Now you can see this is a rectangular load. Rectangular load means UDL. Okay. So first of all, I need to convert this rectangular load or this UDL into the point load. So how I am going to convert that? This length I know it is 5 meter. This intensity it is 800. So the conversion will be, what is the conversion? It is 800 into 5 into. So 800 into 5 means what? It is point load. It is still not a moment. This is point load. We are taking the moment, summation M. 800 into 5 means what? Conversion. This rectangle area, area of the diagram gives you the magnitude of the force, magnitude of the point load. So area of this rectangle will be 800 into 5. Okay, length into width. So 800 into 5. So it is point load. Now where this point load will act? This point load will act at the center of rectangle, that is at the CG of the rectangle. So where is the CG of the rectangle? If this total is 2.5, its CG will be somewhere here. If total is 5, then its CG will be somewhere here. Okay, and the distance is, this distance will be, how much is this distance? It is 2.5. So to take the moment, now my point load is acting through this CG, and now the value of my point load is 800 into 5. This is the value of my point load, but I am taking moment at point A and my load is acting through this point. So what is the lever arm? The lever arm or the perpendicular distance is 2.5 meters. So again I will multiply this by 2.5. Okay, I will multiply this by 2.5. So this is the moment. Now this is moving downward, so it will rotate in clockwise direction. Okay, downward hai na, so it will rotate in clockwise direction. Now see this triangle. Now see this triangular area. So area of the diagram gives you the magnitude of the point load. So now area of the diagram. Now this is triangle. What is the base of triangle? This base is given as 5 meter. This is 5 meter. And this height, it is 800. This is 800. So what is the conversion of point load? UVL into the point load, it is half into base is 5 into height is 800 and now whatever we have done this is nothing but this is point load, conversion of UVL into the point load. Now we have to multiply it by the distance. Now we need to multiply it by the distance. Just we have plotted the area of this rectangle. It is the magnitude of the point load. Now where is the CG? Now I have told you the formula already. For right angle triangle, its CG will be at a distance of B by 3 and H by 3. So B by 3 from right angle. It is at a distance of B by 3 from right angle. Now so see, here is the right angle. This is my base B. So it is 5. So B by 3, 1/3 of that. So here somewhere the CG will be there. Okay. Here somewhere. Here somewhere the CG will be there. And what is the distance? So the distance of this CG from this point, from right angle. Okay, distance of the CG from right angle, because right angle is here on this side. So this distance will be, I will write here the formula also. So this distance is B by 3. Distance is B by 3. So this is B by 3. Okay. So this distance is B by 3. So B by 3 means what? It is 5 by 3. Because your base is 5. This base is 5. So this is B by 3 means it is 5 by 3. But we don't want this distance. Where we are taking the moment? We are taking the moment at point A. So from point A, what is the distance? So this is the distance of the centroid from point A. A point पासूनचं distance पाहिजे आपल्याला, कारण आपण moment कुठे घेतोय? We are taking at moment at point A. So we should take the distance from point A only for multiply it. Okay. So now here, if I show that distance, so we are in need of this distance from point A to CG of this figure. So how much it will be now? This 5 by 3. What is the answer of this 5 by 3? How much 5 by 3 means?
1.66.
So this is 1.66. So this remaining will be, if this total is 5 and this is 1.66, then the remaining किती असणार आहे?
3.33.
It is 3.33. So the remaining is, this is 3.33 meters. So our lever arm is 3.33. So I multiply this by 3.33. Again, if you see the diagram, this is moving downward. This force, this is downward. असे आहेत ना सगळे arrow खाली आहेत. So this is downward. So it will rotate in clockwise direction. घ्या याला खाली ओढून आणि फिरवा. So it is rotating clockwise direction. So this is also positive. So here I will write this is plus. And then at the last minus RB येणार होता. RB किती आहे? RB is moving upward and it is moving in anti-clockwise direction. So minus 5 RB. So minus, it is 5 RB is equal to 0. So now once you solve this, you will get the value of RB.